Alright, welcome to CS50B Introduction to Programming 2 with C-Lane. Click the subscribe button there to get informed with new videos that have been updated and every new update I make. So, let's talk about characters. A character in every programming language we say is a data type. I emphasize on the data type that represents a single letter of the alphabet enclosed within a single quotation mark. So if I pick A and I enclose it within a single quotation mark, then I can refer to it in the word of programming as a character. As we proceed further into the video, I will refer to characters as char because that's actually the way C or every other programming language identifies what a character is. A character is typically 1 byte long. That is to say, it contains 8 bits. That is 8 zeros or 1. So here we are going to use the ASCII table to make reference to our characters because it will be much easier to work with the ASCII table since it has decimals of each character represented in a tabular form. For example, A in capital is equal to 65 on the ASCII table. Capital letter B is equal to 66 on the ASCII table. Capital letter C is equal to 67 on the ASCII table. Keep going that way till you get to Z. For the small letters, small letter A is equal to 97, small letter B is equal to 98, and small letter C is equal to 99. Keep going till you get to Z. But what did you notice? You will notice that the capital letter is not the same as the small letters. Their values are not the same. So when you are comparing a capital letter to a small letter, even if they are the same letters, but in different cases, don't expect the result to be true. We also went further to say a character can either be signed or unsigned, depending on what program you're actually working with. If I am working with an encryption code, a code that takes in data, encrypts it, or hashes that data into some cryptic form that can comprise both negative and positive values, then I think I will suggest a signed character for you. It ranges from -128 to 127 bits. That is the length it takes. Okay. But if you're working with just a plain program that just have to do with positive characters, then you can use the unsigned character type. We'll discuss more about that as we proceed. If we look at strings in C, we notice that C specifically does not contain strings as built in. It doesn't recognize strings. Of course, it does have a header file that stores some functions, some string functions that we can import into our program, our IDE, to perform some functions or some operations with strings. But to recognize it itself as a data type, C does not have that capability. So instead, it stores strings, that is to say words, sentences, paragraphs. It stores this data type as characters. It is preferred that way. But languages like Java, C++, they actually do recognize strings. Okay, but here in C, we don't have a string data type. So instead of doing that, C suggested that since I recognize what characters are, why not I store and since the strings are actually made up of letters, since words sentences are actually made up of letters, and each letter is a character data type, why not I store these words in form of characters? If you know what an array is, we say an array is a collection of same data type. Okay, I have a video on that. You can go back and watch it. But an array, like we say, collects data types uh, of the same type. For example, if I have a collection of just integers, that is an array. If I have a collection of just strings, that is an array. A collection of just floats, that is an array. Okay, so they must be of the same data type enclosed within a square bracket. So a string stores these characters in that array. So an array is going to look this way. Assuming I want to store the word hello, I want to store the word hello, which happens to be a string and not a character. I am going to define, going to declare the variable to store it as characters by saying char x, then define it as an array equal to hello. But in my memory space, it is going to look this way. H is going to be stored at index 0, E is going to be stored at index 1, L is going to be stored at index 2, L is going to be stored at index 3, and finally the last O is going to be stored at index 4. So that is when I want to make reference to them, I can use the index number. I can go about to say, okay, print the element in index 1 or print the element in index 2. So all the string functions in C are predefined, and they are stored in a header file we call string h. That is string.h, meaning string.header file, particularly in C. So maybe as we begin to look at some other examples, we begin to get it better and better. I think the code would actually do that the best. So let's look at some string functions we can actually make use of in C. One of these functions are the ones we refer to as string. Here I am denoting my variable as x. Okay, x is not a constant. You can choose y, you can use name, you can use maybe last name, maybe you can use some other variable names. Okay, it's not particularly to x. I'm just using it to represent my variable there. So what this function does is that it is used to get the number of characters that are present in a string. So like in my previous example where I say I have a character stored in x called hello. Hmm? Now, the number of characters I have on the word hello are 5. Hello. There are 5 characters. So by the time I perform a function called string on that hello, what I'm going to get as my result is going to be 5. Okay, we'll look at an example in the next slide. Then the second one is the string compare, denoted as string cmp. For this string compare, it is going to take in two arguments, two parameters, which happens to be here. I denoted it as x and y. So what it does is that it compares the two strings and see if they are actually the same or not. Let's look at an example, okay? But the string compare will always return a number to us, to return a number. It's not what you expect to see true or false as a Boolean result. No, what is actually going to return to us is going to be a number, and we'll look at how that number is generated as we proceed further. So if x and y are actually the same, the number you are going to see that is going to be returned to the screen is going to be 0. Otherwise, it is going to return some numbers after performing some operation on the two strings. So the next function is the string copy. Here it also takes two parameters, x and y. And what it does is that it picks the value of the second variable. Here, my second variable is y. So it picks the value you have assigned to y and then stores it or replaces the value of x with that value y has. So for example, in my x, if I have x to be equal to hello and I have y to be equal to hi. So if I perform a function, a string copy function, taking in x and y as my parameters, then what it is actually going to do is that it's going to pick hi and store it in the memory location of x. So whenever I print x, instead of displaying hello, what is going to be displayed is going to be hi. It's just like overriding the value, the initial value of x with this new value, okay? And the position matters. If I perform a string copy operation on x comma y, it will give me a different result from performing a string copy operation on y comma x, okay? So let's look at some illustration codes. If you can actually guess the output of this code before we get to seeing the results, I think it means we are learning. So the first function we want to pick here is the string. We want to perform an operation on it. So I've explained the whole syntax of C. I've explained how it works, the environment, and I believe you know what this includes standard IO.h means. For those of you that have not watched that video, I'm just going to make a little bit of recap of what it means. So what it simply means is that C, go into your predefined libraries and pick in a library called the stdio.h. The H stands for header file, but C has to do with a lot of header files. So this stdio stands for standard input and output. It helps us to print to the console and also accept input. Okay, so include this header file. The header file must be contained within angle braces. So include this header file, standard io.h, into my C IDE so that I'll be able to use the printf statement and probably the scanf with some other functions in it. So in addition to that, I also included the string.h header file because previously I said every operation or every function that has to do with string is stored in this header file. I mentioned that earlier on, right? So we have the main function that is on line 3. We have the main function returning nothing. Void actually means nothing. It's a data type also, void. Void returns no output, okay? Returns nothing. You can actually change the value of void to int, to string, to char, but depending on what program you are working with and the type of result you are expecting. So in every C program, just like in Java, there must exist at least one function, and that function is the main function. Okay, you can have every other function, but the main function must be there because it is like the mother of all functions. Every action that every behavior the C program takes is contained within the main function. So I I defined my character here on this line. I defined my character here on line 5. I defined the character data type and attach it to a variable called x. Okay, so x is going to be storing some characters. And what are this list of characters that I have? On the right hand side, I have the list of the characters I have, which are HELLO, which happens to be hello. So hello is going to be stored on the variable x in form of characters. Then underneath that, I have the printf statement, which I explained earlier on, that it helps us to bring out output. Okay, it displays the output on the screen of the computer. So if you look inside the printf statement, you will see some cryptic things there. If you have watched the previous video, you understand what some of these things mean, aside the string function, which I believe by now you already have an idea of. With the printf statement, I have the format specifier, that is the %x that you're seeing there, and the %d. They are called the format specifier. Okay, they tell us what way the result should be presented as. The format S is for strings. Okay, print it as strings. Then the format specifier D is for decimals. Print it as a number, a whole number, an integer. Okay, so within the quotation marks, within the double quotation marks, there we know whatever is enclosed within a double quotation mark inside the printf statement will be printed out the way it is. Hmm? So here we see the word %x, meaning that display the English, the word. And after the word, what you should display should be a string. Okay, what string are we displaying? We'll actually specify that later. Then go to a new line, the meaning of that backward slash n there. Go to a new line and display length of word. Length of word, display it as a number, an integer. So comma x there actually means the variable. And remember, a variable is storing the word hello. So it means pick the value of x and display it. And where is it going to be displayed? It's going to be displayed on this line that says the word %x. So it's going to be the word, and what is going to follow next is hello. Then go to a new line, length of word. The length of word is going to be displayed as a string, as a decimal, okay, as an integer. So it is going to display length of word, string. What is the length of my character, my x variable is going to be 5. So return it to me. Let me see it. So in fact, my result is actually going to look this way: the word hello and length of word 5. Is actually going to be how my result is going to look like. So the second example here is for the string copy, for the copy function. So I first of all, like I said, the string copy takes in two parameters. It takes in two variables. So if I define my first variable as x, here you can go about to delete the 10 you are seeing in between the block braces, but that is just like a validation to me. It is just telling me, okay, whatever word I wish my x value, my x variable to store shouldn't exceed a length of 10. That is what it means. If I change it to 20, it means don't exceed a length of 20. If you exceed that 20, you get an exception. So character x, as in x variable, should store some length of characters, specifically 10 characters. Though my word that I'm saying, it may be less than or equal to, but can never be greater than. So on the right hand side, I have hello, storing hello, and y storing the word elite. So on the line 7, I included the function string copy. So I say copy the value of y to x. If I print it, what I'm going to see is I am going to see my result to be the new word of x is elite. Okay, because x has been overridden from hello and replaced with elite. All right, so the string compare also takes into parameters x and y, but this guy is a little bit tough than the other guys. This guy has more work to do than the previous guys we have been working with. With this guy, I will have to bring in some mathematics, okay, that we will have to relate with the ASCII table. So it will be best if you have your ASCII table beside you, a piece of pen and paper also. So what I did in string copy, I repeated it here somehow. I defined two variables x and y, but this time around x is storing the value of on in small letters. Remember, capital and small letters are not equal in the world of programming. Y storing off in small letters. Then I said display the result of comparison in an integer form. Okay, in an integer form. Give me an integer form. Remember when I said string copy takes in the variables we are trying to compare, compares them, and displays the result in form of an integer. So if they are equal, it will return 0 to me. Otherwise, it will return some number. So if I compare these two strings, the result I will likely see displayed on the string on the screen is going to be 8. So results of comparison is going to be 8. That happens because string compare doesn't actually work by giving us the expected true or false value that we want. Rather, it will pick in the comparison and display it as an integer, like I said earlier on. But how is this integer then generated? So let's say from the example we're given on the program, the value of O is 111. The value of N is 110. That is in small letters. Then the value of O in the second case is 111 also. The value of F is 102. So sorry for the misarrangement here. But if you can follow along, remember we are comparing on against off, right? Right? That is ON at the top and OFF underneath. So the value of O is 111. So the arithmetic we are going to get there is 111, 110. On is just two letters, okay? So I wrote null there to show that it doesn't have a value, just for the purpose of neatness. So minus 111, which represent the O in off, 102, which represent the F in the off, and 102. Remember the third part, the third column has no operation to be performed. So we are just going to ignore that third part, okay? So what we are going to get there is when you perform a minus on them, that is just decimal arithmetic operation on it. What you're going to get is 8. So the result is going to be 8. Let's take another example. This time around, let's use the word affit. X is going to be storing the word affit in capital letter. Y is going to be storing the word affit in small letter. Now, can you guess the output that is going to be displayed or the return value in decimal? Okay. All right. So the output is going to be minus 128. That's the output we are going to see. How did we arrive at minus 128? Is because AFIT, as in AFIT, is 65, 70, 73, 84 on the ASCII table. And in small letters, it is 97, 102, 105, 116 on the ASCII table. Okay, so 65 minus 97 will give us minus 32. 70 minus 102 will give us minus 32. 73 minus 105 will give us minus 32. 84 minus 116 will give us minus 32. Sum them together, the result. So you get minus 128. So does that make sense? You can try other examples, maybe, bring your ASCII table, pick a letter, compare them together, and see what type of result you actually get. So this scanf function is scanf. Why do I need the scanf function? Right? What is the purpose of the scanf function? We use it to accept input from a user at runtime when the program is running. Okay, that is to say the input is to be accepted from the user. It is not to be hard coded into the program. It is not at compile time that the input should be accepted, but rather the input should be accepted at runtime. That is, should be inserted by the user, and we know it is defined in the standard input output header file. Okay, likening this scanf function to other functions in other programming languages, we have scanner class in Java. We have the input in Python. A lot of you will be familiar with that. So the format it follows is that I have this scanf. I call this scanf function. So if I call the scanf function, the function is usually accompanied with a parenthesis. Okay. So in the scanf function, I am going to have a format specifier. I've told you about the format specifier earlier on. That for string is %x, for float %f, for double %lf as in long float, for integers d, and for characters c. So what output or what type of input do I want to accept from the user? I have to specify what data type I'm accepting from the user. It is like a validation. Okay, then the address of the variable I want to store that input in. Okay, so let's look at an example with a code here. So if I want to illustrate the scanf function with a code here, I can go ahead to, first of all, I have to include my standard io.h, meaning, okay, I want to include both the input, because this scanf is included in that package. The printf also is also included in that package. Okay, so I declare my main method. After declaring my main method, then I start writing my blocks of code. And the first thing I might want to do is to declare my variable. And here I decided to change from using x, so as for you to know that it's not just x and y. So I say my name variable here is going to store a length of 20 characters. Okay, then after doing that, I defined an integer. I declared another variable called age to store integer values, because we do know that age is an integer. Okay, so the next thing I might want to do is, okay, go ahead and display a message to the user and print out a statement. Please enter your name, and then the cursor should go to the new line. And after going to the new line, what should happen? Create a space for that user to actually impute the name you are requesting for. And name is a string. Do not forget, name is a string. So the format specifier here is %x to indicate that I am taking in a string value. Okay, I'm passing that value to the name variable. So take note of the ampersand, the ampersand sign there. It is used to get the memory location of that variable. Okay, like I told you, a variable is a memory location. So if that variable is stored at index 1, it is going to say in index 1, go ahead to store this value in index 1. So it is going to get the variable location, and then pass that value that the user is going to type into the program to the name variable. Okay, then after I get the input from the user, I want to go ahead and accept the second input by saying print another statement. Hello, please can you enter your age? Please enter your age on a new line. Then accept the age. The data that is going to be passed to the age variable is going to be in form of an integer with a format specifier of d. We have cleared the air around that earlier on. So go ahead and do that. And after collecting this data, print out the final message. And what is the final message? Your name is %x, which I explained earlier on, that is going to be displayed in form of a string, and you are %d is going to be displayed in form of a decimal years old. So what are the parameters that are going to be displayed? So I have name and age. They are the two things that are going to be displayed. Okay, so the result we are actually going to see is your name is let's assume the person entered John Doe. So your name is John Doe, and you are, let's assume the person imputed 5 years old. So you are 5 years old. Okay, so do not forget after all this to return the value. Okay, the return 0 is mainly for your operating system, not actually for you, but it will be of good coding ethics to actually include the program will still run without the return 0, because you already have your print statement. And lastly, do not forget to add your curly braces. They are very important to show that, okay, this is the end of my main method. This is the end of my block of code. Okay. So with all this being said and done, it will be a good idea for you to, practicalize them, you know, run them out and see. So another abstract example. So you can try to guess the output of this code.